Alexandre, I teach here. I'm supposed to introduce these guys. The reason I'm in this room is I looked over the description of the presentation, and I realized that for probably a decade I've been interested in these topics, decentralized communication, encryption, things like that. Unfortunately, more than that I can't tell you because I don't know them, but I'm sure we'll learn everything we want to know. In this talk. It's going to be fun for sure. That's why I'm here, and that's why you guys are here.
Thank you.
Thanks.
All right, welcome everyone. I'm Alexandre, and this is Adrien. We are from Savoir-Faire Linux, and we're here to introduce you the communication platform we've developed called Ring. Quick start. This is the main goals we wanted to achieve with Ring. We wanted an easy-to-use, free distributed communication platform. It means we don't want just a piece of software like Skype is. It's just a desktop environment, desktop software. We wanted a real platform that could be embedded in Raspberry Pi, routers, desktop as well, but just desktop is just one of the use cases we wanted to cover. We wanted Ring to be secure, robust, and mostly in the major thing was to build on open standards, because it's not what Skype or Hangout or Google in general are doing. They're doing closed communication with proprietary protocols. It's like what TOX does also. It's the same principle, decentralized communication, but based on their own protocols, the TOX protocol. That means that TOX can only talk with other TOX clients. It's just another VoIP client. And so this project is a free software project based on license on GPL v3, built by 6 core developers at Savoir-Faire Linux, and more and more guys coming, because it's a really day-to-day piece of software. We are texting, we are calling, and we are communicating every day. And for now, all the solutions are not open enough. So Ring was previously called SFL phone. You may know it. It's a SIP phone. It was a SIP phone. It's a project developed by Savoir-Faire Linux as well for a decade now, and we revamped it as Ring the late 2014. What is SIP? I'm not sure everyone knows what is SIP. It's a standard, open standard in business and enterprises, and in the communication world in general. The main principle is there is a server that serves as a register for every client. Every client is a SIP client. Each client has an account on this server, and the server is basically an index where you just you want to communicate with Bob. Bob has that IP address on this server, but the problem is there is a middleman. There is this server and between the two clients, and without it, you just can't call anyone. It's not working. So what we added in Ring, it's the decentralized communications. It means we removed the server between the peers. Everyone that is using Ring is a small part of this server. Every client knows some other nodes, what we call nodes, like it's other people using Ring, And when you want to call someone, you just ask to some of them, do you know Bob? And this kind of request propagates until we reach the peer we want to contact. And it comes back, and the call is made after that. So we are all kind of small servers, small indexes, and it serves to just remove all infrastructure needed. We are all clients and servers.
Yeah. So we're going to make a demo so you can have a feeling of what Ring is and right now. And so currently this is the Ring GNOME client. We have a client for OS X, for Windows, and there is also a community-driven KDE client. We're also building an Android client, which is not currently over, but it is under heavy development. So this is what Ring client looks like. Also, the UI is under heavy development, and we need hands. So, if you're interested, we're gonna Ring right here is in the same state as you will get it just after installing it. Maybe except the call history on the left. So when you start it for the first time, you have no subscription, no kind of a registration to do. There is no central authority. When you first start Ring, it generates an RSA keeper, and that RSA keeper will be used to identify you. And at the core of Ring is this number, which is like a phone number. And that's how you reach other people, by sharing your phone number, which is actually a public key, signature. So here I'm gonna call Alexandre's computers here.
What you see here, the ugly hash, you see, it's the number of this computer. So I just got the call here. I'm gonna answer it. And here we go. So what we did here, from this computer, we made a request on the public DHT network, the network where all other Ring clients are registered. And this laptop made a request. I want to talk to this, what we call Ring ID. It's really nicer than hash or public key. Finally, we found the peer. So what is made after that, it's basically a SIP call. It's a call like when you call a Polycom or it's built. There is no magic here. We don't have a Ring protocol, or it's fully interoperable with other Ring clients and SIP clients and phones who are using SIP.
Yeah. So it's using the standard and the robust SIP protocol, which is used, for instance, to say, oh, I'm making a call. It's used to negotiate the codec that is used. It's used to, when the other person hangs up or pauses the call, that is the SIP communication protocol that is used in enterprise, etc. And what you saw there is that in a few seconds, just by giving just a phone number, I could make a direct IP to IP call with a peer everywhere in the world, and without using any central server or without depending on any central service. The call is fully encrypted, and there's no central point of failure, and I will show there's no possibility of man-in-the-middle attack, etc.
Should we do screen sharing?
So in this client, we already implemented many features. So for instance, I can do a screen sharing.
Actually, you won't see it. Oh yeah, you can see the preview of what you're sending, and on my laptop, I don't see the camera anymore. I see the screen area that Adrien took.
For instance, I can also I can also drag and drop a file, for instance, and it may appear. It will be automatically streamed instead of my video stream.
Yeah, and I can enjoy like Homeland or anything that my peer is just sending me.
And all of this without any central server, without any central authority. All of this is fully peer-to-peer, except the initiation of the connection which uses the public distributed DHT network that I will mention in a few minutes. We are also building in conference and this kind of advanced feature as well that will be integrated in the next few weeks.
Okay. So
how does that work?
Yeah, what we are gonna do briefly, we're not gonna go much more in details of security and everything, just we're gonna explain how Alice can call Bob in this massive network and distributed network.
Yeah, so there is no server. So how does Alice knows what is Bob's IP address, which can change all the time, and how does Alice has confidence that she's actually talking to Bob and not someone else? So OpenDHT is a software library we built from scratch because there was no such thing available actually. So who knows what a DHT is? Not many people, maybe a few. So I will try to explain it very briefly. So maybe some of you know BitTorrent. When you download a file over BitTorrent, in the past there was a server centralizing a list of IP addresses of people having a file. But then there was legal actions taken against those servers, so they were taken down. So now how do people share files using BitTorrent? There is what is called the BitTorrent DHT. Maybe some of you have seen the magnet links. So those magnet links are actually linked actually keys in the key value shared data store, which the DHT is. So as I mentioned, the DHT is a key value data store. It is a database that is shared between all the participants. Every participant owns a little bit of the data in this data store. So the data is replicated between multiple participants. So if a participant leaves, the data stays here. And any participant can access any data using an iterative algorithm that is based on the 6 degrees of separation. Maybe you've heard that between any two people in the Earth, there is about 6 degrees of separation, or a maximum of 6 degrees of separation, taking into account social interaction. So I know someone that knows someone that knows someone, and with a maximum of 6 degrees of separation, I can reach basically everyone in the world. So the same principle is used by OpenDHT, so that we can find some data on the distributed database in a very efficient way. So actually, Bob's. So how do we use that to make calls in Ring? So Bob listens for changes on this distributed database. So he asks the peers responsible for holding the data, hey, if there's a change for my ID, please inform me. And so when Alice puts her encrypted IP address on the distributed database, Bob is informed, and he can, and if he accepts the call, if he trusts Alice's certificate, then he will reply back with his own encrypted IP address on the DHT. So everything that goes on the DHT is fully encrypted. The only thing that may appear at some point is the IP address of participants, like every other participant of the DHT network, but nothing more. And at the end of the day, both participants end up with the other participant's IP address that was encrypted for him only. And at this point, the DHT network is not used anymore. And we do a classic SIP call using the standard SIP protocol. And we do it in a very special way so that we can go through firewalls and through NATs and this kind of thing. So let's say that Bob is behind a firewall. So Alice wouldn't be able to establish a direct IP communication to him. So since both peers have the IP address of the other peer, they will both try to establish a communication. And so that Bob will try to reach Alice, and that will work. The same way like when Bob contacts a normal server online. And after the IP communication is established, we established a TLS communication. At this point, we can check, each peer checks the other peer certificate, check that it's the same certificate that we use on the DHT. So there's a continuity of the cryptographic operation. An interesting thing here is that we use a very bleeding edge TLS technologies that allows us to provide perfect forward secrecy. So even if your computer is stolen, and even if someone recorded the encrypted communication, they cannot even recover the communication itself using YuKey because it was using some temporary key that is already lost at this point. And over this TLS communication, we establish as classic SIP call, as we mentioned. And that, obviously, all of this is encrypted.
So, what Ring does and what it does not. This is the objectives we wanted to show you, because it can be unclear what is encrypted, what is shown to the other peer, what can we do with that. So the goal with Ring was to assure the user about data authentication and integrity. It means that a man-in-the-middle attack is not possible. What you got from any peer, it's identified. It's this peer is sending this to you. Nobody can forge packets and give them, or just send you fake packets, or pretending to be someone else. Each peer is identified, and the communication is secured. The other point is the data exchange confidentiality. It means that no one can record or listen on what you're saying or sending like a video or text messages. It's a encrypted channel, so NSA too bad for you. I mean, on this side, you are the only recipient of the data you exchange.
Yeah, so it's an IP to IP communication. So obviously, someone recording network activity will be able to see that there is a network activity between those two IPs. But the communication itself will be encrypted with perfect forward secrecy. So the communication itself will not be recoverable. But that metadata will be leaked in that case.
Yeah, we can't assure about complete privacy. It's not like Tor. We don't hide metadata information. This is not the point of Ring. We don't want to hide people. We want to hide what they say and what they exchange, like what data, what file they want to share. So your internet service provider can know you're trying to use the DHT network, as well as other nodes that can listen on request about what's going on the network. So it's not a complete privacy. And it was not our goal from the beginning. So it's just to be clear on that, and it won't be the case. It's really difficult to find who is using Ring. I mean, it's fully encrypted and everything, but there are ways to find about IP addresses and peers using Ring. But
however, the communication is never going to go through a central service So the communication is never going to go through Google or through Facebook or anything like that. So there will be no possibility, like if you're, I don't know, if you live in Europe and you contact another person in Europe, the communication will never go through the server of an American company like Google with all legal implications that it has. For instance, it really uses the internet as it was meant to be, that is a decentralized communication platform for peer-to-peer communication between IP to IP. And that's what internet still is, we hope. So we're going to talk a bit about the Ring as a platform.
Okay, so why we use the term platform and not just software? It's because the way Ring is built, it's decoupled in two packages. We got the daemon. The daemon has no UI or anything. It's not what we show you. We show you a front end, a client. What is a daemon? It's just basic C++. It's the core, the core engine of communication, of using DHT, of sending audio, video, and SIP calls. Everything is handled by this guy. It relies on free software components, typo here, FFmpeg or libave for audio, video, PGSIP for the SIP protocol and communication. It's a free open source stack, SIP stack, and OpenDHT, the component we are developing.
This is a software library we built from an existing code for the BitTorrent DHT. We adapted it for our needs because the BitTorrent DHT, in the BitTorrent DHTs, IP addresses are not encrypted, and the IP addresses, unencrypted IP addresses, are the only thing you can store in the distributed database of the BitTorrent DHT networks. So we built our own DHT library that is much more powerful with encryption built in, and it's a free software project on GitHub. So it's it's opendht.net. It redirects to the GitHub page.
And so the daemon can be shipped in. This part of Ring that can be shipped in Raspberry Pi or BeagleBone. We have one actually hooked up here. So and the daemon is running on it. So we're gonna do. What's the name? Yeah, we're gonna try to do just a quick call with BeagleBone and see how it works.
Okay.
We have here it is. We can show you here because the power source is it's over here, so it's too short. But it's basically a really small board and with Ethernet cable, a USB camera, and that's it. Okay, daemon is running. In the meantime, I can show you, I can tell you a little bit about the UI. So this is the Ring ID you're gonna need to share. When you install Ring, the software is gonna generate for you the Ring ID here, the huge number, the large number. This is what you need to share with your friends. You can send it by text message or email. And this is the number that are going to. And
okay. So now I have the BeagleBone here. We're running the Ring daemon on it, and I'm gonna call it from here. So I'm gonna call it using the pure SIP protocol. So I'm gonna type here the IP address of the BeagleBone, and hopefully. Oops, looks like we have a little problem here.
Demo effect. It's happened again.
Yeah.
Can I
So-
distract you with work on it while I talk to you?
Yeah.
Is that okay? I don't want to slow you down on your demo.
Est-ce que ça peut marcher ou pas?
Yeah, so no, switch on. Yeah, because there's an API. There was an API break, so there's a small incompatibility here. But
Okay.
So can you handle both ends behind that?
yeah, so that is a work in progress. But there is an ongoing research with a team at UQAM University in Montreal, and so what we're working on is indexation. It's data indexation on the DHT itself. So currently, this is a research problem. So if you are looking for a torrent file to the online, you cannot do this in a distributed way. Most torrents are distributed through the BitTorrent DHT network, but if you want to find it, you cannot do it on the distributed network itself. You will need to go to some indexing site, like the Pirate Bay or this kind of website, with many ads and this kind of things. And those sites today are just an index of known torrents with associated magnet linking to the distributed network, the DHT. But in the future, maybe, yes? So in the future, maybe we can do indexation on the DHT itself. So we don't even need those sites anymore. We can do keyword search directly on the distributed network. So that's what we're researching for in collaboration with UQAM. And that will allow us in the future to select, according to some criteria, random nodes and using those random nodes, those random third-party nodes, to retransmit the communication in case both nodes, both peers are behind a NAT or a firewall. If both peers are behind a NAT or a firewall, it's technically impossible to establish a direct IP-to-IP communication between them in most cases. So for many cases, like if you are at home, most likely you have UPnP enabled by default on your router. So we use that. So if you're at home, you will have no problem. If one of the peers is not behind a NAT, that will work out of the box. So if you're at home and you have UPnP, you will be contactable publicly, and so you will be able to contact anyone, even if this person is behind a NAT. And in the future, even if both people are behind a NAT, then we will select a third person and establish a TLS communication that will go through this third person. And so this third person will only see the encrypted communication going through, and that's it. But it's difficult because, for instance, there will be an Android version, so we wouldn't want the data to go through an Android phone because that will be too unstable and that will consume people's mobile data. So there are a lot of constraints, but this is a work in progress.
It would be like a service, like one Ring user could say, okay, I can act like a proxy between two users between NATs, and it will broadcast this info. Okay, I can do that on the network, on the DHT, and so peers stuck behind NATs will use this one as a proxy to communicate. This is done actually now by Turn servers. Like Turn gives you the real IP address, but I mean it's some setup, and we don't want the user to manually register a Turn server or something like that.
Actually, the BeagleBone received the call. It's just we have a Python script controlling it, and this Python script will require some update to work with latest development.
Ok, on va reprendre la présentation. Okay, where will we?
And we have received many requests on GitHub from people working on hobbyist project using the Ring daemon because it's not only a decentralized communication system. It also still works with the classic SIP protocol, so you can configure it. If you have if your phone operator provides you a SIP account, which is common in Europe, for instance, then you can use Ring and configure it so you can make actual calls to actual phone numbers using Ring, and also to Ring numbers. So people actually take this kind of BeagleBone or Raspberry Pi, put the Ring daemon on it, and they can build an actual wooden phone with old style the dialer, and it works, and it's awesome. And there are quite a few people who interacted with us on GitHub about this kind of project.
Okay, and now front ends. So this is what we show you, the GNOME client. At Server Linux, we are developing the OS X, Windows, Python, and Android clients. So it's a lot of work, and that's why we are trying to make a lot of things at the same time. So it moves on, but slowly. Yeah, thank you. These ones are already downloadable on our website. The Android one is still under development and will be soon available on the website as well.
But you should check it out. It works out of the box. You can just start it. It generates an RSA keeper. It shows you the number. You can give this number to a friend. He will paste this number inside his Ring, and it's going to establish the call, and it works already.
So it binds on the daemon via dbus, which is a bus IPC protocol, or static linking. You can package everything in one binary. This is what we do, for example, for OS X or Windows. Because this is how we deploy stuff. We just drag and drop an app on macOS X in the application folder. So we wanted to package everything. So it can work both ways, either through IPC in two different processes, the daemon and the clients, or in the same process. No UI necessary. I mean, you don't have to have a fancy UI. It can work just via Python commands or command line instruction. You can just tell the daemon what to do. I want to make a call to this Ring ID. It's just one command line. So it's really easy to start to customize it for a specific use case. Yeah, it allows system integration, flexibility for system integration as well, since we decoupled the core communication and the clients, and I already told you about the Python API. What's to come? So this is what we are currently working on. This is a roadmap for the end of the year, Christmas, a lot of gifts. Text messaging. So text messaging is it's a challenge for us because we don't have an actual server to store messages. Just imagine you have you're on Ring, you want to talk to your father or mother. You say, hey, hello, but your mother is not connected. She's not registered on the Ring, on the DHT network. Where does the message go? We don't have a server to store it and give it to her when she just turns the Ring on. We have to find a new way to store messages. And it's actually what we are trying to figure out with the UCAM University. It will be stored on the DHT, but we need to define rules because otherwise we'll have a lot of messages on the DHT and we'll just flew the network. So we need to define rules and life cycle of a message, like maybe after 2 or 3 days, a message that can't be delivered is destroyed, something like that. It's an open world. We have to find new rules. Conferences and call transfer, this one are almost ready. They should be packaged and shipped with the nightly build on the website really soon. Conferences, I mean, it's a basic feature for SIP phones or any video software. We already had it in the previous project, SFL Phone, and we are now just finishing and polishing things to make it work with ring calls. I mean, there's a bit of mechanics under the hood. So. And
it's very powerful to be able to make a conference in a fully decentralized way, without any server, without any central authority. You just call 3 different people, you make a conference between them, and in terms of bandwidth, we mix the multiple videos inside a single video, so it's possible. It's actually possible for people to upload this and to be a mixer for the conference. Yeah, it's almost working. I mean, it's already implemented. It just requires some polishing.
When someone make a conference with, for example, let's say I want to make a conference between my brother with Ring and my I don't know, my other brother with a SIP call. I mean, he has a SIP account and a SIP extension, and the other one is on Ring, but he doesn't know about SIP. He doesn't have a Ring account, SIP account. So I can call one with Ring and call the other with SIP, with Ring, with my setup, and after I can hook them up in the same conference. They don't know. I will act as a mixer of the conference. I will host. I will receive their audio and video feed, mix them together, and send them back. So basically, you can hook someone from outside an enterprise with your. I mean, for example, the client you're working with, and the colleagues inside an enterprise. They have all SIP extensions. You can call the client with Ring and create a conference from inside the enterprise. You don't need any infrastructure. It just works out of the box for everyone. The client and all your colleagues can make a conference a really quick way. So this is the website, ring.cx. Ring is quite a general term, so it's ring.com was already taken, and we just tried .cx, and it's easier to remember as well.
So if you are a developer, you will find developer resources from this website as well. Yeah. You will find access to documentation.
Yeah, how to build, how to make how to deploy on the Mac OS X, on Windows. It's all the documentation is on the website. You will have link to our source code. It's not on GitHub yet. We use Gerrit for integrating our code. So we have the Gerrit hooked up on the website. You can access it and see what we are currently working on. But I'm pretty sure we will release it on GitHub, like a mirror or something. So that's it. We try to not be
too technical.
But if you have questions, we are here. Yeah, indeed.
So is it like BitTorrent in a way that you're hosting other people's video conferences, for example, or is it more like a DCC direct to two-way communication without relying on a network?
You mean
like if I'm running Ring, yeah. I'm not talking to anyone, am I hosting?
No.
Okay.
No. When you make a conference, I mean, you're on Ring, you call one person, another one, you say, let's make a conference, you hook them together and you act like the host. But if you're not part of conference, you're not going to host it. What we told earlier, it's when two people are stuck behind NAT, like they can't reach each other. But if they use a proxy, like someone in the middle that can reroute their communication, it will act as a server. I mean, like a server, they retransmit the communication, but it's not implemented yet, and it's still under development.
How do you deal with, the notorious latency in the public internet, right? Latency, drop packets, all those things that WAN optimization tries to deal with. How does that play into your solution?
Yeah, so we built adaptive bandwidth technology so that the bandwidth used is automatically adapted to the capacity of the link, which is a technology implemented by major communication solution providers like Skype, Hangouts, etc. But most smaller projects don't have this feature, so we worked a lot to have it so Ring can work even in bad network conditions, and even, yeah, I've been on a trip to India recently, and I've been able to establish a good high quality call with my father, and it was very nice to see that working. Yes?
In terms, because I know you were mentioning you could have a conference call, and you could have the person, the mixer would be the central hub for all communications that would mix the conversations and then rebroadcast out to each individual peer connected to the conversation. In terms of load balancing on a network, I guess that central hub would have to have a very strong, stable connection in order to be able to receive and retransmit. Is there anything that could be done to maybe shift the role of the hub to a stronger connection within the group, or would that ruin privacy in a way? I know you mentioned that you could include people in the conversation that aren't part of the group. Like you could add a contact that's not part of the group. But then if you were to shift the hub, that could ruin privacy. But could something like that be done? For example, like if the person who's I guess initiating the conference call has too weak of a connection to be the mixer, can the system adapt to that and maybe shift the hub role to someone with a stronger connection?
Yeah, that would be a great thing to explore in the future. So we're in a completely peer-to-peer. It's a completely peer-to-peer way of communicating. So to communicate in a group, maybe not all of the people in the group know each other. So how to do it in a trusted way and automated way? It's a challenge for sure.
Yeah.
But yeah.
What we already do, it's we integrated a couple of weeks ago. It's adaptive bitrate. We react on bandwidths available and adapt the video quality based on that. So let's say one peer has a really poor connection and the other has a perfect connection. They will have info on what they can send, when they can support, and adapt on it to lower the resolution of the frame sent in order to have a more stable connection and a better visualization instead of packet drops and artifacts. This is already a first step in this direction, but shifting the conference to another peer, it's huge. I mean, you have to renegotiate audio, video streams, trust issues about the other peers. It's not possible right now, but sure, that would be the best case scenario.
Yes.
So your signature hashes for going between different users, they're ugly. I feel like I'm back in the ICQ days.
Yeah.
Welcome back. Welcome back. Thanks. Has there been any thought on adopting DNS-based schemes like enum or text records for translating these signatures into human-friendly forms.
Yeah. But the challenge is how to do this without breaking the decentralized philosophy. So obviously, if there is a central record of association between email addresses and hashes or profiles and addresses, we could even use, theoretically, we could even use the Facebook API to, so that you could find your friends' hashes, and maybe we will even do that. But we really want to keep it completely decentralized, and we really want to not depend on a centralized service or server. But we are totally aware that copying hashes is not optimal in terms of user experience. So we are really thinking about how to make it more.
That's why we integrate with contacts on different systems, because we want to hide the hash as soon as possible. I mean, you have a hash, you call the peer once. The next step, you can just take the hash, add to contact, and choose an existing contact or create a new one. After that, you call your brother or your colleagues, and you don't call a hash. And when you start using Ring a lot, you have like different hashes. Okay, so yeah, my mom, it's 7BC. Yeah, no, it's not working.
Even currently, well, yes, you can add some hash to contact and create a new contact, but it's not optimal. It's completely not optimal yet. Yes?
I guess when you guys implemented on Android, you could always just use QR code, perhaps to carry that rather than having to type it in manually.
Yeah, that's there are some really cool way to share the Ring IDs on mobile, but we need to find ways to make it work on desktop as well. And this is we're still working on that. Yeah.
First of all, DNS isn't a centralized system, but it isn't a distributed one, right? DHT, where does that run? I don't do BitTorrent, so I'm not up to speed on that. But you said that there was nothing running on a client's machine except their own stuff. That's not where OpenDHT server runs? Like distributed?
Yeah, so actually, yeah, so the OpenDHT is a decentralized network. It's a distributed key value data store,
Right.
but it's very lightweight. For Ring, we only use it. The only values we put on this distributed data store with Ring is the encrypted IP addresses. So it's only a few hundreds of bytes, and that's the only part that is public. So every Ring client will run an instance of OpenDHT and will retransmit for the people very small packets of a few hundred bytes, which are encrypted IP addresses.
So you are running a little bit of stuff on it.
Yeah, exactly. And that's very low overhead protocol. That's a very low overhead protocol that even if you look at your network bandwidth, you're not even gonna notice it because it's very low background networking.
If you want to pierce that, could you advertise not your IP address, but the IP address and port number for your gateway? Would that work?
Yeah, that's actually currently supported. So if you're a company and you want to use a Ring inside your company, you can run a turn server, which will be a relay server, and you can configure this relay server inside Ring, and it will be added to the encrypted IP address you put on the DHT, and the other person will try to use this relay to connect to you in a completely automated way. But the next step is to choose random relays online that are willing to be relays and to use them randomly to establish the TLS communication using those relays.
So like, I hate NAT, so I don't really understand it completely, but and I have the luxury of a whole bunch of IP addresses. But as I understand it, most simple NAT blocks is like your home wireless. They tend to allocate to an outbound screen a port number and an IP address, and they don't care what, for traffic coming back, they don't care what the source port is, the source IP address. Is that correct? So if you have one piercing of your NAT, it'll work for anybody outside, not just for the people you wanted to talk to. Is that true?
I'm not sure what, sorry.
Okay, maybe that's too complicated for a question and too fuzzy.
No,
I just wonder whether you don't even need to have a turned server. You need somebody to discover what your NAT has given out, because you don't know. If you're the client behind NAT, you don't know what your public IP address is.
Yeah.
And you don't know what port number it's given. But if you can discover that.
Yeah, the thing is, when you most modern NATs, when you contact some external service, will assign you a new random port for every new connection. So you will not be able to predict what will be the external port assigned to you by the NAT, unfortunately. And the first generations of NATs used always the same port or used a sequential port. So it was possible to predict what external port will be used. And that was used, for instance, by Skype, which had a very aggressive way to bypass NATs. And in part because of this, in part because of the Skype behavior, the NAT design were stepped up, and now you cannot do this anymore. Yeah.
Any more questions?
Any other question? Yes.
What does the encrypted traffic look like for the router?
It's a TLS connection.
Does it look like HTTPS?
Yeah, exactly. It looks exactly like
It's not going to block it because it's special kind of encryption.
Yeah, exactly. It looks exactly like a standard HTTPS connection.
And speaking of the, is that a public key fingerprint, the ring ID?
Yeah, it is.
Can't you just sign your name with your key and publish that?
Well, the goal is that if you just do this, someone else could take the same name, sign it, and
Right, but if you're trusting the key will always, the signature will always stay with the name. Right? So you have to trust the key regardless.
well,
But this way you don't have a name associated with it.
what you actually trust is not the public key. What you actually trust is the private key behind it, and the fact that there is a private key available to.
Right. So you can't sign your name without having a private key.
Oh, you mean okay, yeah. So.
Because I'm saying, instead of giving that to people, give your name signed with your private key and that. So then you can find your name on the public network. Does that make sense?
Maybe, but what would prevent someone else from thinking? If at the end of the day you end up transmitting a signature, it will look the same as this.
Well, partly do that, but partly will be human readable. And the human readable part will be more convenient.
Possibly. Well, actually, it's in part we were planning to do this. So we're building a V card, including your name and maybe your contact picture, and we're signing it, and it's going to be automatically transmitted and exportable to give that to other people as your identity, and it will include your public ID, obviously. And so instead of a hash, you may have like a contact card that will be a file, and when importing this file, there will be automatically all the information associated with it, like the name, the contact picture, this kind of thing, and it will make it much more visually compelling and yeah. But we're really exploring this kind of idea to make it to try to hide the hash as much as possible for end users, but we still want to keep the safety and the trust, and we must preserve the chain of trust, and that's challenging to do.
There are many use cases we didn't think about. So ring can be used for like a variety of I mean, the sky is the limit. You can ship it and you can use it for example, security systems. You can like plug cameras and have a building monitored. We talked this morning with a guy from Able, and he was working on a project to make different university campus work together. And he said like one campus is using Microsoft Skype, the other one is using Google Hangouts, and when they need to work together, they can't. So this is some of the kind of solution that is like agnostic. It's not bind to a company. I mean, everyone can use it. That's why we want to support multiple platforms, and that's why we went with audio and video for the first use case. I mean, it's the most obvious use case. Give audio, video, and conferences to users, to end users, because it's a visual thing and it will help them understand it, and after that have new ideas of new use cases for Ring.
And if you think about it, email is much less powerful than many modern communication solutions provided by, like, say, Facebook. But email is still massively used. Why do we still massively use email? Because it's an open standard that everyone can use without relying on a private company. And so despite the fact that email may be considered outdated technology, it is very much used and will still continue to be used in the next years only because it's an open standard that anyone can implement for free. And that's what we're trying to provide with Ring. Yes?
Do I recall that you said you're using PGP to generate those signatures?
It's raw RSA keepers.
Okay.
But actually so yes, there is we don't use PGP, we use X509, but we use X509 in a very unorthodox way, if I may say. So we build, instead of relying on a set of root CAs built in your computer, we add the possibility to add new trusted CAs from the Ring UI. And so that you can, for instance, if you want to communicate with another company, you can add this company's CA into your Ring. So you will be able to contact and trust certificate from this company employees. Or if it's for standalone use only for you, the first time you start Ring, it's gonna automatically generate you a new CA and sign a certificate with the CA. And you will really be able to either only trust someone else's certificate just to communicate, or trust his CA and other certificates signed by him. So we really made it more powerful than the standard X509 relying on a hard-coded list of trusted CA.
So, follow-up question. From a user interface perspective, how difficult is for me to take my next new laptop and add it as also me Ring client? So take that CA, move it over, and generate a new Ring ID that is signed by that, and makes it clear that these two come from Ring.
Well, this is the kind of thing that will be, in theory, very easy to do, but we just haven't implemented it in the UI. So all these kind of tools are not ready yet, but it will be trivial to do with basic command-like tools to generate certificates.
For now, what we added, to generate your Ring ID, you can provide the key and certificate. The basic use case is you let Ring generate them for you, but you can use your own if you want when you create a new account. So if you do that on both of your laptops, they will identify it will be the same you. Over. later on.